Hey guys, this video is about the periodic table and organizing the elements. Okay, this is chapter 6, section 1. It's very short and brief. There's a few important people that we need to discuss, as well as some areas of the periodic table, some basic areas. All right, in chemistry, first question is organizing important? Well, the answer is yes. There's an organization that falls in the periodic table. We have different groups, or also known as columns, and we have the periods. Now, the next couple chapters, we will be looking into the differences between everything. So, the first scientist to actually understand there's some kind of organization with the periodic table was Dmitry Mendeleev. He was a chemistry teacher, and he created the first periodic table around 1869. He had on it roughly 63 elements, and because he was a teacher, he understood their physical properties, their masses, and how they interacted with each other. So he had to teach students how to use these elements, and no other better way than to arrange them on note cards and organize them according to their specific properties. Now, a very interesting note about Dmitry Mendeleev is that his table was developed before anyone knew the internal structure of the atoms and were pretty closely placed to where they are today. All right, so Dmitry Mendeleev's table was a pretty important table. Um, Elements were arranged a little differently, and they were in order of increasing atomic mass. Okay, and the rows went vertically. Um, and with the elements with similar properties and groups, they went horizontally, so they're a little different. Okay, we didn't discuss the chemical properties yet, but basically, his table was turned 90 degrees. Okay, and he also left several question marks where no elements fit. Okay, so he knew that it's got to be something here. Okay, because we have all these other elements laying around in their correct spots, how I'm laying them out, but there's got to be something in this empty spot. Okay, so here's his table. Okay, you have 1, 2, 3, 4, 5, 6 vertical columns. Now, here are the question marks I was telling you about. Okay, they were later discovered. Like this is gallium and this is germanium. Now, some of the facts later found: scandium, gallium, and germanium were later discovered and placed where there was a question mark. Tellurium had a question mark next to it. Te. He placed it out of order with iodine. Okay, because he knew iodine belonged with bromine and chlorine. Also, if we notice, the mass of argon is greater than potassium, yet they're in the order, so check that out on the periodic table. Gold was moved. Platinum, rhodium, and manganese were also moved. Okay, now let's look at the modern periodic table. Since technology on discovery the proton, electron, and neutron were out, um, scientists revisited the properties of elements and were able to further improve their understanding of them. There was a scientist, his name was Henry Moseley. Okay, of course the H is cut off, looks like Henry, but it's Henry Moseley. Henry Moseley published the modern periodic table in 1911. Okay. It's based on scientific evidence called Moseley's Law. Not getting into it today, it's a little lengthy. Okay, so basically, he wrote Mendeleev's periodic table. Okay, what he ended up doing was he arranged elements by increasing atomic number. Okay, so we were able to determine the number of protons. That's what he did. So he took everything and rearranged it to where you put them in order of increasing protons. Now, the new periodic table followed something called the periodic law. Okay, periodic law is where elements are arranged in order of increasing atomic number, and there is a periodic repetition of the physical and chemical properties. So as you go left to right across the periodic table we use now, you go from one group to the next. Each group contains different chemical and physical properties. So therefore, when you go left to right, you're going to enter a new class of chemical and physical properties. Yet when you start over the next row down, you're repeating the same chemical and physical properties as you go left to right, the row down as the one above. Okay? So, for example, uh, group 1A elements, all of them from top to bottom, are reactive with water. All of them. So every time you get to the element in the first group, bang, it's going to have that reactivity property. And as you go left to right, it's going to change. Back to the first group, there it is, a repetition. And it's going to be the same repetition going left to right. All right? Just to use group 1A as an example. Now, this is what our modern periodic table looks like. Okay. It has 18 groups from left to right. You have 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Those are important. And then you have the lower ones, which are the Bs. Now they have a different a numbering, but we're not going to worry about those right now. Then you have your 7 horizontal rows. But there's 3 areas, okay, that are important. You have your metals here. You have your essential non-metals here. And you have your metalloids here, except for AT. AT is not considered a metalloid. This is technically a halogen here. All right, so boron, silicon, germanium, arsenic, antimony, and tellurium are the 6 metalloids. Okay, metals. Okay, is an element that conducts heat and electricity well. Okay. Properties of metals include they react with acids. It's majority of the periodic table. Most of the elements in the periodic table are metals. They are solids at room temperature, most of them. They are malleable. So think of like a mallet, a hammer. You can hammer into sheets. And ductile. They can be drawn into fine wire. So the ductility of a metal is to be able to be pulled into wire. Whereas copper is a good metal that can be very ductile. It can be stretched into very, very, very hair-like fibers. Okay. Gold is a very malleable metal to the point where it can actually be so flat it could be almost transparent. Okay. Make it very, very thin. Now, mercury is the one metal that is liquid at room temperature. All right, so here we have a picture of gold, copper wire, and this is some kind of something wrapped in aluminum foil. I guess in the comments below if you know what this is. Let me know. It's interesting. Looks like a chicken leg or something. Someone's lunch. Okay. Now, nonmetals. They're on the right side of the periodic table. A lot of them. Good amount, sorry. A nonmetal is an element that is a poor conductor of heat and electricity, meaning electricity is not going to go through it. Okay? For example, a diamond. It's not going to really conduct heat or electricity well. Well, nonmetals are found majority in the P block. Most of them are gases. And if it's a solid, it's very brittle, like sulfur. It's like powder-like. Okay, so here's a picture of sulfur. We used to be able to use sulfur in school, but we're not allowed to use it anymore. It actually irritates your skin. If you have sensitive skin, it'll irritate your skin. Here's carbon. All right, phosphorus and iodine. Now, metalloids. Metalloids sit in between nonmetals and metals, so we can say they're a little bit of both. Okay, so metalloids are the ones that form that staircase, and when I say staircase, this is what you want to refer to. Okay. A metalloid is an element that has some characteristics of metals and some characteristics of nonmetals. Okay, so here are the 6 again. And some properties are they are also solids at room temperature. And they semiconduct, meaning kind of conduct electricity. And depending on the mixture of elements with metalloids, they can either conduct electricity poorly or well. So that's where like computers come in. Okay, you could have a mixture, kind of like cooking, different kinds of cookies, different kinds of cakes. You can mix these elements up in certain ratios to allow electrons to flow at certain speeds or to help dissipate heat. And that's it. One fact that I forgot to mention was about Henry Moseley. Henry Moseley actually was, yes, a scientist, but he also served for the Great Britain's military, and he was a very influential man on science, very well respected and very intelligent. Unfortunately, he had to enlist in World War I, and during World War I, I guess in the front lines, he was actually killed in action. So he was technically, they say, one of the, and almost like an Einstein. And science lost him. So he actually could have helped this out a lot more, but he was lost during World War I. All right, guys, that's where I'm stopping. Take care.